assignment. The question is why KNN is considered as a lazy learning. Discuss K nearest neighbors. Consider the following table. It consists of the height, age, and weight targets value for 10 people. The weight value of ID level is missing. Pick the weight of this person. Good. So now let's move on to the question number 10th, which is the last question of the assignment. Why the KNN is considered as lazy learning. Discuss K nearest neighbors. Consider the following table. It consists of height, age, and weight, target weight value for 10 people. The weight value of ID 11 is missing. Predict the weight of this person ID 11 based on their height and age. K nearest neighbor KNN algorithm. Okay, so what is KNN? K nearest neighbor, commonly called KNN, is a supervised machine learning algorithm. It is mostly used for classification, but it can also work for regression tasks. The idea is simple. Whenever we get a new data point, we look at the k closest point in the data set and make a prediction based on them. So why is KNN called a lazy learning algorithm? KNN is considered a lazy learning because it does not learn anything during training. Instead of building a model in advance, KNN simply stores the entire data set. It waits until a prediction is needed, and also then does it calculate distance and identify the nearest neighbors. This means there is no training phase, but the prediction phase becomes slower because of calculation happens at the moment. That's why we call KNN as a lazy learner. And how KNN makes predictions to predict the output of a new point. KNN follows a simple rule. For classification, it checks the category of the nearest neighbors and chooses the majority class. For regression tasks, it makes the average of the value of the nearest neighbors. For example, imagine we have two categories: red diamond representing category 1 and blue squares representing category 2. Here we can see that. So, if a new point appears, KNN are blue squares, the algorithm will classify the new point as category 2. So, KNN works purely on proximity. The closer the point, the more fluental they have. So, what is the K in KNN? So, K is simply the number of neighbors the algorithm considers. If K, it looks at the three closest data points. If two out of those 3 points belong to a class, the model chooses that class. So K plays a crucial role in determining prediction accuracy. So how do we choose the best K? So choosing the right value of K is very important. If K is too small, the model becomes sensitive to noise. And if the K is too large, the model may become too simple and start underfitting the data. Common techniques to choose K includes cross-validation, the elbow method, and using odd value of K to avoid ties. So the distance matrices used in KNN are to find the nearest neighbor. KNN use distance formulas, and the three most common ones are Euclidean distance, the straight line distance between 2 points, Manhattan distance. Here we go. Euclidean distance, the straight line between the 2 points. The formula, as we have already studied from many years, is under root of x minus x ij whole square. You can understand that. So the Manhattan distance is measured along grid-like paths like city blocks. So formula is given by summation of modulus x I upon yi, and the Minkowski distance, a generalized form of distance that includes both Euclidean and Manhattan depending on the pattern P. So if the formula goes as summation of xi minus yi to the power p, and the whole to the power of the summation also is 1 by p. So this matrices help the algorithm identify which data points are closest to the target points. So steps of K-NN algorithm are, or the working of the K-NN algorithm are, so it chooses the value of k, calculate the distance between target point and all other data points, select the k point, the smallest distance. For regression, take the average of the neighbors value for classification, use majority voting. Okay, so let's take this example of a numerical table given by height, ID, age, and weight. So let's solve the given example where they have height, age, and weight for 10 people. We have a missing weight for ID 11. Height is 5.5 and age is 38 for this person. We will predict their weight using Canon. So to keep some things simple, we choose k is equals to 3 because the average is somehow, and the most common height is 5.6 and it is representing towards 3, and let's choose k is equals to 3. So we use height and age as features and calculate the Euclidean distance from ID 11 to all other IDs. So all the distance are given in the table. For example, distance to ID 6 is approximately 2.02, and distance to ID 5 is approximately 2.12, and distance to ID 4 is approximately 4.02, and so on. So identify the three nearest neighbors. After sorting distances, then ascending on the three nearest neighbors are ID6, ID5, and ID4. ID6, ID5, and ID4. And predict using average regression. The weight of this nearest neighbors are ID6 is equals to 60 kg, ID5 is 72 kg, and ID4 is 59 kg. So we take the average of these three values. So after averaging, the prediction weight of ID 11 is 64. So therefore, the answer of the uh, uh, remaining weight 11th order will be 64. 64. Yeah. So to summarize, KNN is simple, powerful, and intuitive. It is called a lazy learner because it does all the work during prediction instead of training. It relies on distance, similarity, and neighbor voting to make predictions. And as we saw, by using height and age, we were able to predict the missing weights value using the KNN algorithm. So if you found this explanation helpful, don't forget to like the video and subscribe for more machine learning tutorials. Thank you so much. That's it for the today. That's it for today. We have done the question number 10, and we have seen it by many different virtues, and we have also taken out the gradient distance here in the table. You can see it in the PPT. So we will arrange this in ascending order, and then we will find the nearest neighbor, the 654 which we got, and after that we will see their weight and we will take an average of it, and the average is approximately 63.67. So the approximate answer of the panel weight prediction of ID 11 will be 64. So this concludes the assignment questions. This was the 10th question and the last question. So in the upcoming next video, we will be moving on to the internals questions which we were given. So thank you so much, guys.